So now we look at chapter 7, which is energy of a system. So we will need to see what we mean by energy and what we mean by a system. So energy is something that's very common, but it's not so very easy to define. So people think of petroleum or wind or solar as energy, but these are mostly what we should say sources of energy. The energy itself can be defined as the capability or the capability to do work. So if something can do work, that thing has energy. And that of course would bring us to what do we mean by work. So we'll look at work in a minute, but before that let's see what is a system. So a system is a collection of objects. It may be a single particle or it may be a number of particles, all within a system boundary. So there would be a system boundary, which may be just an imaginary line outside this region or an imaginary surface. Everything inside is the system and everything outside is the environment. So the environment is outside the system and it could be the entire universe, but the system could be very small, could be very large. The whole earth could be one system. This room in which you're sitting could be a system, or you could have a small container which would be a system. A system does not have to have a physical boundary. It could be just an imaginary boundary also. Now, we now look at what we mean by work. So work is something that's very different in physics and in general English usage. In physics, work is said to be done when a force pushes something or pulls something and it makes it move over a distance. So it's force times a displacement. So you apply a force and the object moves by some displacement, some distance. So then we would say that the force has done some work on that system. So the force is doing the work on this object and the object moves. Now if you stand in front of a wall and you keep pushing the wall and keep doing that for hours, you would get tired. You might even get paid for it, but because the wall doesn't move, the work is zero. If the displacement is zero, then there is no work. So for work you have to have a motion. Something has to move in order for work to be done. Now we say work is the force time displacement, but let's suppose that we have a surface. Let's say it's a frictionless surface and we are pushing something like this. So this would be the force. The object would slide along the floor and after some time it would reach here. So if we consider the middle of this to be x equal to 0 and the middle of this as x equals, well, this distance, which let's write it as delta x. So it has moved a distance delta x from here to here. Then the work done would be the force times the distance. But the force is acting in this direction and the distance is, or displacement is in this direction. And one of the things we need to add in here is that it's the force times the displacement in the direction of the force. So both the force and the displacement must be in the same direction, which they are not. So we have to take the components of the force and we take an x component, which is in the direction of the displacement, and we get a y component. So we break up the force into its x and y components. Now the y component is this way, but there is no displacement in the y direction. The x direction is this way, and the displacement is entirely in the x direction. So the definition is that force times the displacement in the direction of the force could also be written as the component of the force that is in the same direction as the displacement. So the work would be Fx times delta x, and the Fy times delta y in this case is 0. There is no delta y. So Fy does no work. All the work is done by Fx. And we know that Fx is F cos theta if this angle is theta. Therefore, we can put that in here and say work is F cos theta delta x, or we can write it as F delta x cos theta. Now, if these are just the values or the numbers, the magnitudes. Now, if you want to write it as a vector, then we know that F dot delta x vector is written as, well, that's a dot product. So, and the dot product is written as the magnitude of F times the magnitude of the second vector times the cosine of the angle between them. So the work is properly defined as F dot delta x, because then it becomes the same as what we have here. Now the units of work would be the units of force, which is newtons, and the units of displacement, which is meter. So a newton times a meter is the unit of work, and we also call it a joule, written as a capital J. So Newton meter is a joule. So you can either say Newton meter or you can say joule. And work is F dot delta x, or whatever symbol you want to use for that. Now, we need to look a little bit more into what we mean by this dot. That is the dot product, and we can also call that the scalar product. So we now go to the scalar or dot product.